5.
Hello, good afternoon, everyone. Welcome to Unions, Intersections, and
Five
Complements.
is 1, right? When x is 0,
Yeah. So today we start with a disclaimer, and it is this disclaimer on the use of artificial intelligence. So the content presented is the intellectual property of the South Carolina Department of Education. By participating in this event, attendees agree they will not record, capture, or share its contents without permission. Attendees agree they will not use artificial intelligence to capture or summarize the contents of the event. The Department of Education reserves the right to remove attendees using these services. So on today's agenda, we're going to be discussing unions, intersections, and complements, which is geometry with statistics, DPSR 3, standard, and the indicators are 3.1, 3.2, and 3.3. Well, I'd definitely like to start with saying welcome and thank you for all you do in teaching and educating the students of South Carolina. I'm going to start with the standard. Begin with this quote. Geometry does not teach us to draw these lines, but requires them to be drawn. Isaac Newton. What resonates with you from this quote? You can put your answer in the chat or you can unmute and share. What resonates with you from this quote? Okay, you have a response in the chat. It reads, it does not teach us, but requires us to learn through exploration. Very good, yes. You learn through the necessary parts of geometry. Good. Let's talk about it. Our standard reads to solve problems involving the probability of compound events in real world situations. And our indicator asks students to describe categories of events as subsets of a sample space using unions, intersections, or complements of other events. When you read this indicator in standard, what resonates with you? What keywords tell you what students should be able to do after learning this indicator? You can put your response in the chat or you can talk about it with us. What keywords tell you what students should be able to do after learning this indicator? And what do you notice about this standard in our first indicator? Okay, we're going to be talking about unions, intersections, and complements. Good. What else? Describe, not just find. Excellent, right? Other events. We are making connections, yes. Okay, so we have union, intersection, and complement. Can anyone on here explain what symbol belongs with union? We're going to start with union. And what keywords help you know which symbol to use? So for union, what symbol do you think you would use to notate a union? You can put your answer in the chat or you can unmute. Good. It's the U symbol. What keywords do you kind of look for when you're talking about unions? Okay, we're joining together, united. All right. So we're talking about unions. The symbol is a U. A keyword you may see when you are reading something about unions is or. And an example would be A union B or be A or B. For intersection, what symbol do you think you would use for intersection? What keyword would you look for? And then we'll talk about an example. So what's a symbol? You can put it in the chat or you can unmute, and a keyword. Okay, upside down U, right. Keyword and, all right, good. So this is what you would see when you're writing and you're talking about describing an intersection, be A intersection B, or A intersect B. Now for the complements, what type of symbol would you see and what keywords would you notice? Okay, we can have a C prime, great. So for complement, you could see several different symbols. So you may have a lowercase c that's a superscript, or you'll have a tilde in front of your A or B, or you would have a prime symbol behind whatever letter that you're using to describe your event. Now, when we're talking about this is important, students know these differences and they're able to describe them and use them correctly. All right, next we're going to talk about indicator 3.1. Now, some process standards that we can be on the lookout with this is our problem solving process standard, our connections process standard, and our structure and patterns. We're going to start with our Venn diagram. I'm going to put some numbers in. Oops. So this is our sample space. Well, I would like for you to think
Victoria
of a
has her
possible.
Victoria has
Yes,
her
Victoria.
hand up.
Sorry, just real quick, going back to complements, since there was 3 different notations when we're teaching our students, should we emphasize all 3 notations? Would it matter if we stuck with like the small c prime? Just asking.
I would teach them all 3.
Okay, thank you so much.
And yeah, because we don't know how they'll see it, and different curriculums may have it used different ways.
Okay, thank you so much.
You're welcome. All right, so looking at A and B at this Venn diagram, what is our sample space? And what do you think, what's a possible description for our events? So we have 2 events. We have event A and we have event B. What are the possible description for our events? You can put your response in the chat or you can unmute. Okay, our sample space is numbers 5 to 20. All right, good. So what are our possible description for our events? If we had event A and event B, how would we describe those events based on this Venn diagram? Okay, you could use different movies showing in the theater. We went by theater numbers. You're right. What's another not so complicated way? Event A, all right. We have event A is 7 through 14. Okay, good. B is even composite numbers. Okay, great answer. All right, let's go to the next slide and let's see. Got one more question for you before I move to that next slide. Are A and B events mutually exclusive? Now, what I want you to do before you answer this question, I want you to put yes or no if A and B are mutually exclusive, but don't send it until I say go. So I'm gonna give you just a minute to type in yes or no if A and B are mutually exclusive. Ready, set, go. Hit the send button. Okay, we have some yeses, some nos. All right, the correct response is no, they're not mutually exclusive. Why are they not mutually exclusive? Who can either unmute or put in the chat? Why are A and B, events A and B, not mutually exclusive?
I would.
Very good. They share numbers, yes. There is an
Open
intersection.
that door.
That's correct. All right, we're going to move on. Our sample space. You were correct. Our sample space is 5 through 20. So we have all the numbers inclusive of 5 and 20. Our two events were numbers between 7 and 14 inclusive. And we say inclusive because 7 and 14 are included in that subset of numbers. And event B is multiples of 2. What would be considered the subsets of our sample space? What is considered a subsets of our sample space? Put your answer in the chat or you can respond. Okay, we have an answer. We have those that are not in the intersections. Do we agree with that response? Our subsets of our sample space. Let me ask you this. Are there some numbers that are not a part of our two events? Are there numbers in our sample space that are not a part of our two events? Yes. What numbers were not a part of our sample space and our two, I'm sorry, that are not a part of our two events? 19, 55, and 17. Great. That's correct. All right, now, how asking students to organize this information using the symbols. We're going to start with the first one. So we want to know, what is A intersect B? What numbers would belong on the first row, A intersection B? You can put your response in the chat or you can unmute and answer. Good, 8, 10, 12, and 14. What about the row A union B? What would our outcomes be for A union B? You can place your answers in the chat or you can unmute. Okay, all but 19, 15, 5, and 17. Great, exactly. All right, what about not A? So what would our numbers be, our outcomes be for not A or the complement A? Okay, we've got 5, 6, 16, 17, 18, 19, 20, and 15. And we got a few other numbers in there also. Would we have something similar for the complement of B? What would be our outcomes for the complement of B?
Off of a
Okay. So we have 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, and 19. And what about our very last row? A intersect not B. Good. 7, 9, 11, and 13. Excellent. Now, would an activity like this is simply numbers help students understand and see a little better how our subsets A and B are related? You can place your answers in the chat or you can respond. Is this an activity that you can use with your students when introducing unions, intersections, and complements? Yes, it is good. What else do you notice about what we've just done? Did we just take one indicator or are we covering multiple indicators at one time? We used all of them, right? Okay, you have your hand up?
Yeah, I have a question. I was kind of in my mind was thinking that in Algebra 2 is where we'll get more into the notation pieces with probability. This feels very notation heavy. So I guess this is kind of an aha for me that I was thinking that that would be saved. Excuse me, the notation. It's a little more abstract and that we would be saving that for the later course, but you're recommending that we do it here in geometry. That's my question.
Yes, it's a part of your standard and your indicator. And because it was not explicitly said not to, that you couldn't introduce it this way, we want to introduce it now because in Algebra 1, that opens up the ability for them to see this on any future assessments they may have. So this will kind of get them ready for their ACT, SAT, and some other places. They may actually see the use of symbols and notations. So yes, they need to see this in geometry with statistics. And even though this part with the symbols is abstract, if you were to do this in class using number tiles or numbered or some type of manipulative, then that brings in the concrete. And even when you draw the Venn diagram with the representational, before we even get really any further into the symbols, if that makes sense.
I think I understand the use of the Venn diagram. Can you say a little bit more about how you would use number tiles? Like are you saying as a substitute for what we're looking at on slide 12? Maybe you could say a little bit more about that.
What I'm saying, like number tiles, like if you wanted to do 2 hula hoops or 2 circles on a desk where they're actually manipulating. So when I say number tiles, where they're actually placing the numbers in the places that they belong, whether it is the even numbers. And in subset A, where they were using the number 7 to 14, and then they were putting the numbers that were between 7 and 14 that were also even. So it gives them a visual where they're actually manipulating their responses.
Okay.
All right, let's try it out. We have a question from Accelerate Learning Math Nation. And we've got the math classes for which incoming freshmen are registered at a local high school are shown in the Venn diagram. So we see our 2 classes, Algebra 1 and Geometry. How many students are included in Algebra 1 Union Geometry? So Algebra 1 and Geometry, how many students are included in Algebra 1 Union Geometry? You'll get 380, all right? Explain what the number 80 in the Venn diagram represents in context. So what does that number off to the side 80 represent in the context of this situation? Very good. Students that are not in either of the courses. Great, it's the complement, exactly. So we have 80 students who are not enrolled in Algebra 1 or Geometry. Now, explain whether the events of freshmen registered for Algebra 1 and Geometry are mutually exclusive. Yes, they are mutually exclusive because the circles do not overlap, meaning there are no incoming freshmen registered for Algebra 1 and Geometry. Great. Okay, let's look at indicator 3.2. Now for this indicator, we're going to explore we can see used math process standards and problem solving, connections, analyzation and justification, structures and patterns. All right, this one, we're going to talk about applying the addition rule to find the probability of both mutually exclusive and not mutually exclusive events and interpret the answers in context. So when you read this indicator, what resonates with you? What should students be able to do after learning this indicator? You can place your answers, responses in the chat, or you can unmute and discuss. They can interpret the answers. Do they make sense? Yes. Interpret the answer in context of the situation. Yes. They mutually exclusive. Exactly. They need to know the difference between mutually exclusive and not mutually exclusive. Exactly. Good. All right. We have cats and dogs. So a customer is planning to adopt one animal from the shelter. Are the events of choosing a cat or a dog mutually exclusive? Okay, we have a yes, yes. Okay, we have yeses in the chat. Explain. They can only adopt one animal. Exactly. Now, could these two events have any type of intersection? Right. Because if these 2 events were mutually exclusive, that meant that they would be able to adopt a pet that is a cat and a what? A dog, which that is not possible. So these events will be mutually exclusive. Okay. All right, now let's talk about it. I'm gonna go back to this one. We have 25 dogs, we have 16 cats, and we have 9 that are neither a dog or a cat. So for the number of animals, and we have dogs, we're going to put 25 in that column. For cats, we're going to put 16. And for neither a dog or nor a cat, we're going to put 9. So now, determine the probability for each event. So what is the probability of choosing a dog from the total amount of animals that we have access to? Place your answer in the chat, or you can unmute and respond. Okay, we got 50%, good. We have 25 dogs out of a total of 50 animals. So that places us at 50%. So what's the probability of choosing a cat in this instance, in this example situation? Great, it's 16 out of 50, or 32%. So now, I would like for us to discuss how the probability of choosing a dog and the probability of choosing a cat can be used to find the probability of choosing a dog and the probability of choosing a cat. What would we do to find this probability? You can place your answers in the chat, or you can respond. Great, we're going to add them together. All right, we got 41 out of 50. So it's important that students understand that it's not the probability of choosing a cat and a dog. Because this is a union, we're combining our options. Yes. We have our hand raised for question.
Yeah, question from
Yeah,
Victoria.
Yeah, so like the verbiage that you're using in C with the end, like wouldn't that end is an intersection? Wouldn't we want to say the probability of choosing a dog or a cat?
Yeah, it would be or.
Okay, all right. I just wanted to make sure.
So we're trying to figure or dog or a cat, yes. So our percentage would be 82%. And let's look at this other question. This is taken from Solvis Envision, and it's an example that you can use in your classrooms if you're using this curriculum. So you roll a 10-sided number polyhedron that has the numbers 1 through 10 on its faces. Each face has a different number. You observe the number that ends up on top. So we're going to let A be the event that the number is less than 6, and B be the event that the number is even. So when we say a number is less than 6, and this is clarification for students, what numbers are we talking about? You put your answer in the chat, or you can respond. 1, 2, 3, 4, and 5. Great. 1 through 5. Now we're talking about the number that is even. What numbers are we referring to in a polyhedron? Great. 2, 4, 6, 8, and 10. Okay. Now looking at our responses, find the probability of A, probability of B, and the probability of A and B. So what's our probability of A going to be? Place your answer in the chat, or you can respond. Great. Probability of A is 5/10. What's the probability of B? It's also 5/10. Great. So what's the probability of A and B? I see we've got 8/10, 8/10. Does anyone have another response? Oh, we have 20%. All right, so we have two different answers. We had 80% and we have 20%. So explain your answer. Explain how you got 20%. We'll start with 20%. You can come off mute and explain. Okay, only 2 and 4 are in both categories. Right. So that is where they would intersect. Good. So that's where we get 2 out of 10 as a response. Oh, you're looking at question. Yes. Question 2 is to find the probability of A plus the probability of B minus the probability of A and B. So for question 2, our answer would be exactly that. And this time the response would be 8/10. Okay, that's correct. Now, find the probability of A or B. What is the probability of A or B? Right, it is 80%, exactly. Because there are 8 numbers that are either less than 6 or even. Exactly. Good. All right, let's look at indicator 3.3. Now, in this indicator, we're going to also be able to see problem solving, connections, analyze and justify instructions and patterns as our process standards. Let's talk about it. So in this indicator, we're going to be applying the multiplication rule to determine the probability of independent events and interpret the answers in context. So we've already discussed the standard. When you read this indicator, what resonates with you? What stands out? You can place your answer in the chat or you can respond. Okay, we've got independent events, good. Interpret the meaning of the answer, yes. We're using the multiplication rule, correct? Apply, yes. So we're not asking students to just solve, we're asking them to apply the multiplication rule in determining independent events and interpret the answers in context, which means we're not looking for just answers. We want to know how their response relates to the question or the situation that they're solving. All right, we're going to start with a bag that contains 10-letter tiles, each labeled with a letter of the alphabet from A to J. Valentina randomly selects a tile from the bag. Valentina chooses a tile, records the letter, replaces the tile in the bag, and then chooses a second tile. Explain whether Valentina randomly selecting the A tile and then selecting a B tile are independent events. So who would like to explain if what Valentina did was an independent event? You'll place your answer in the chat or you can unmute and respond. Okay, we have a response in the chat. It's independent due to the replacement. She returns the tile to the bag, so the first tile does not affect the second selected. Great. They are independent because she replaced the tile after her first selection. Exactly. And these are explanations or descriptions of explanations which we should hear in conversations with students. All right, so knowing this, what's the probability that Valentina chooses an A tile on her first draw? All right, we got 110. Good. What's the probability that Valentina chooses a B tile on her second draw? Great, it's still 110 or 10%. All right. So what is the probability of Valentina choosing an A tile on her first draw and a B tile on her second draw? Excellent. It's 1 out of 100. I see an expression. We have 1/10 times 1/10. Exactly. All right. So here's here's an activity for you to do. Write an expression to find the probability that the first tile drawn is a B tile, followed by an A tile, followed by a G tile. What would that look like as an expression? Very good. It'd be 1/10 times 1/10 times 1/10. And these are independent events because each time Valentina is replacing the tile back into the bag. Now, how would this change? How would the probability change if she were to draw an A tile, followed by a B tile, followed by a G tile, without replacing the drawn tile? What would that expression look like? We have in the chat 1/10 times 1/9 times 1/8. Good. That is what the expression would look like.
That would be an algebra 2 standard though, correct? Like with the one without replacing.
I would have to look that up and get back to you. I'm not right off the top of my head. I could not tell you. Okay, let's look at the spinner, and this is from Salvis Envision. Are these spins on a spinner mutually exclusive? Yes. Why are they mutually exclusive? They have no overlap. The spinner cannot land in two colors at once. Good. Okay. So now one does not affect the other exactly. So looking at this question, you spin the spinner 2 times. Assume that the probability of blue each spin is 1/3 and the probability of orange each spin is 2/3. What is the probability of getting the same color both times? So what's the probability of getting color B 2 times, blue? And what's the probability of getting the orange color 2 times? You can place your answer in this. Good. It'd be 1/9 for blue and orange 4/9. Very good. That's correct. And these pens are definitely mutually exclusive. Okay, do we have any other questions? Don't have any questions? We have one quick last quick activity. I'm asking for you to please complete your formal reflection for today. We ask that you take a moment to complete our survey. This helps us determine what needs were met today and what needs we can touch base with you about at a later time to make sure that we're supporting you as best we can. And when you fill out the survey, you should automatically receive your certificate since you were attending this live session for your credit. If you don't receive a certificate once you fill out the survey and complete it, please just email me and let me know so I can make sure that you receive yours. And I know the first webinar haven't received their certificates yet, but you can be expecting those in the next couple of weeks. Once you fill out this feedback survey, I hope you all have a great rest of your week and a wonderful afternoon.